Welcome to this explainer. Today, we're decoding the beautiful, swirling structures of spiral galaxies that literally populate our entire universe. I am so thrilled to guide you through this because, honestly, these cosmic structures are some of the most stunning and mysterious phenomena we've ever observed. We're going to break down exactly what makes them tick using centuries of incredible data and history. So let's just jump right in.
Let's kick things off with a slightly provocative question. When you look up at the night sky, what exactly gives the cosmos that iconic, signature swirl? I mean, you've heard of them, you've seen the images, right? Those breathtaking pinwheels of light just spinning out there in the dark void. But what forces are actually at play shaping those arms? Are they solid structures, or are they just optical illusions? Well, we're going to answer all of that today.
But first, to understand why this really matters, we need to talk about scale. Together with irregular galaxies, spirals make up a staggering 60% of all galaxies in today's universe. Think about that for a second. If you point a telescope into a totally random patch of the night sky, the vast majority of what you'll find out there shares this fundamental architecture. So understanding the spiral galaxy really means understanding the very fabric of our cosmic neighborhood. Section 1. Meet the spiral galaxy, from nebulae to island universes. Now, our historical journey into figuring this out is wild. It shifts from 1845, when Lord Rosse thought these were just clouds of gas within our own galaxy, all the way to Edwin Hubble proving they're actually entirely separate island universes. Back in the 19th century, Lord Rosse looked through his massive telescope, sketched out the Whirlpool Galaxy, and, well, he didn't actually know what it was. He just called it a spiral nebula. And this sparked the famous Great Debate of 1920. Were these swirls inside the Milky Way or outside of it? It wasn't until Edwin Hubble found these pulsing stars, called Cepheid variables, in 1923 that we finally proved these were entirely separate galaxies, millions of light years away. Fast forward a bit, and Hubble's groundbreaking 1936 work officially cemented the spiral galaxy into the classification system we still use to map the cosmos today. In his famous book, The Realm of the Nebulae, he laid out what we now call the Hubble Sequence, organizing galaxies purely by their shapes. He gave the spiral galaxy its formal definition, setting the stage for basically all of modern astrophysics.
Section 2. Anatomy of a spiral. Dissecting the cosmic structure.
So a spiral isn't just a simple flat disk. No, it's a highly complex system. It's kind of like a cosmic nesting doll. First, you have the flat, dusty, rotating disk where all the action happens. Then, right in the middle, there's a dense stellar bulge of older stars. And hiding right in the center of that bulge is usually a supermassive black hole. Then you have those gorgeous spiral arms. Now, they're bright specifically because they are packed with massive, incredibly luminous young OB stars. And finally, holding the whole shebang together, extending far beyond the visible light, is a massive, near-spherical halo of invisible dark matter.
Now, the crucial point here is that right outside that dusty, rotating disk is something called the spheroid halo. This is a completely dust-free zone where the galaxy's absolute oldest stars just wander around in highly irregular orbits. We're talking about population 2 stars, ancient, red, and completely lacking the heavier metals that you'd find in the disk. Some of these stars were actually stolen, acquired from smaller galaxies that the spiral swallowed up over billions of years. So it's this chaotic, ancient halo surrounding a very highly ordered disk.
Section 3. Our barred galactic home, the Milky Way's secret bar.
Okay, let's talk about the dramatic evolution of galactic bars over time, because it really shows how rare they used to be compared to the modern universe. If we look way back in time, like 8 billion years ago, only 10% of spirals had these elongated, bar-shaped distributions of stars cutting across their centers. But as the universe matured, things shifted. Today, over 66% of spirals in the visible universe feature this distinct bar structure connecting the central bulge to the spiral arms.
And guess what? It turns out our own Milky Way is actually part of that 2/3 majority. We literally live in a barred spiral galaxy. And this was a fact finally confirmed by the Spitzer Space Telescope. See, for the longest time, astronomers thought the Milky Way was just an ordinary unbarred spiral. Because we're sitting right inside the galactic disk, looking toward the center is incredibly difficult. It's kind of like trying to figure out the shape of a forest while you're standing behind a super thick row of trees. But infrared data from Spitzer pierced right through all that dust and proved, beyond a doubt, that a massive bar of stars stretches right across our galactic core.
Section 4. The winding problem, the paradox of the arms.
This brings us to a really fun physics whodunit. Since the inner parts of a galaxy rotate way faster than the outer parts, shouldn't the spiral arms just wind themselves up tighter and tighter until they disappear entirely? I mean, think about it. If the stars near the center are completing their orbits so much faster than the stars out on the edge, any radial shape should just get stretched out and coiled up into a tight, featureless blur after just a few galactic rotations.
Well, an astronomer named Bertil Lindblad realized this exact paradox way back in 1925. He proved that spiral arms simply cannot be permanent, fixed structures. They aren't like the spokes on a bicycle wheel. If the arms were made of the exact same stars permanently locked together, the laws of physics and differential rotation dictate that the spiral shape would have been destroyed billions of years ago. If they were permanent, the galaxy would look less like a beautiful pinwheel and more like a tightly wound ball of cosmic yarn. Yet, we see these perfectly preserved spirals everywhere we look. So how is this even possible?
Section 5. Creating the cosmic swirl. Solving the cosmic whodunit.
To solve this mystery, scientists have two leading models. The first is the SSPSF model, which suggests that stellar winds and massive supernova explosions create shockwaves that ripple through the galaxy, triggering self-propagating star formation. Basically, shockwaves trigger new stars. But the other major hypothesis, the density wave theory, proposed by Lin and Xu in 1964, is something far more mind-bending.
To understand the density wave theory, think of the arms as cosmic traffic jams. And hey, they're probably the only traffic jams in the universe that create something beautiful instead of just pure road rage. According to this theory, the spiral pattern revolves at a different, much slower speed than the gas and stars themselves. As clouds of gas fly into this slow-moving wave, they start to pile up. This local mass density increases, squeezing the gas clouds, which triggers what's called the Jeans instability. The gas clouds collapse under their own gravity, birthing brand new, brilliantly luminous, massive blue stars right on the leading edge of the arm.
So, the huge takeaway here is that stars and gas are actually just passing through the arms. The arms themselves are basically an optical illusion created by a migrating wave of high density. Just like cars don't stay in a traffic jam forever, stars and gas enter the spiral arm, they get slowed down and compressed, and then they eventually emerge out the other side. But because those incredibly massive bright blue stars die out really quickly, they only illuminate the area right where the jam is happening. This leaves a darker background of fainter stars behind the wave, making that beautiful spiral shape pop out brilliantly.
Section 6. Conclusion. Looking back in time.
Let's wrap up by looking at an absolutely incredible number, 12.4 billion years. That represents the age of the light reaching us from a galaxy called BRI 1335-0417, which is currently the oldest and most distant known spiral galaxy. Now, because of the vastness of space, looking at distant objects means we are literally looking back in time. The light we're seeing from this galaxy was emitted a mere 1.4 billion years after the Big Bang itself. It completely challenges our understanding of galaxy formation because it tells us that these complex, grand design spirals were already out there spinning in the very, very early universe.
So, it leaves us with one final, massive question. If perfectly structured spiral galaxies could form so soon after the chaotic dawn of our universe, what other mysteries are hiding out there in the cosmic dark, just waiting for us to look up? These swirling islands of light aren't just beautiful. They are dynamic, ever-changing engines of creation that have been churning out stars since the dawn of time. I really hope this explainer has given you a profound new appreciation for the spirals that decorate our universe. Keep looking up, keep asking questions, and never lose your sense of wonder.